Hello everyone, my name is Jacob Vogelsang. I am a contributor to the CoMPAS project, and in this tutorial I would like to show you two plugins, 2.5 plugins that we ship with the CoMPAS distribution that allows you to manipulate and manage the data type template section of your project. Let me start from scratch with an empty SEL file and show you the first plugin, and we call template generator. That plugin allows you to create new logical node types in your data type template section and add them to your data type template section. The plugin is based on so-called NSD files, namespace description files. Those are XML files, code components shipped with the standard that you can download from the official homepage of the i6-2050 or IEC. And these files, they contain the tables that you can see in the part 7-4, 7-3, some enumerations and other structures, structured types, also from the 8-1 and the 7-2. Now, in these tables, when you unfold them, when you put them all together, is nothing else than the tree of the maximum possible L node type, whatever you choose. So in this case, for the LPHD, but let me show you other ones. Like I would like to do it with the GGIO. You see? So you see all the data objects that you can add to a GGIO with the standard namespace and all the structure of all the data objects, CDC classes. All right, now this super tree, as I call it, so the maximum possible logical node type, this is something that you can select from. So what we save to the file is whatever you have selected, the selection, the subtree of it. Like in this case, at the moment, only behavior. As you can see in this preview. At the moment, I just create a logical node type with the class GGIO, and I only have one data object, behavior, and that data object requires me to generate and to create one enumeration type because the stval is of B type enum. Now, and then the reason why this one is already selected is because the standard states that some data objects and within data objects, some data attributes are mandatory. Now, behavior is mandatory for all logical nodes. It must be there. And behavior is of the type ENS, enumeration, status. And that has some data attributes that are also mandatory and must be there. In addition to that, we pre-select all enumeration types. So you can deselect them, but as a default, they are selected just because some of them are very long and it is very common to just have all enumeration types in. All right, and then I can go on and add data. For example, I need an indicator. Actually, I need two indicators. Now with this one, this is of type O multi. So you can have multiple of those in. This is why we instantiate at least one with the number 1. But I can add another one. So I know this is an SPS. And I know this is I must start with indicator, and I would like to have the second one. By the way, we check in the NSD files if this fits. So if there is a data object with that name, then we see that's an invalid DO, right? Okay, and what I do is I extend the supertree with such a data object. Because I can, it's of type O multi. And then in addition to that, I would like to add another data object that's of the type ACT, right? And this is my trip, for example. Now, whenever we find a data object that we cannot find anywhere in the namespace description that we can assign to a CDC within a specific logical node, we enforce you to give us namespace definition. This is what also the standard states. So this is my trip signals, something like that. Okay, and then as you can see, my trip. Yeah, we've added this ACT type with enforcing the data namespace to be there. So this is where you encode the non-standard namespace. And if you look at this, you see the elements that I write into the SCL file, they grow. GGIO, now I have a behavior indicator 1, indicator 2, and then my trip. And my trip is specified here, including the data NS with the my trip signal in. Okay, when you're done selecting whatever you need to have, you can add the type. We force you to give a description. So this is my GGIO. And if done so, you write this stuff into the SCL file. Yeah, the plugin that is very close to the data type template structure is the so-called template editor that shows you what you have created in detail. One thing that is interesting here is the IDs of the type. So very often IDs are human readable, and you read like whatever vendor, a specific purpose, and a specific version, something like that. We choose to work with so-called hashes. So our ID is based on the content of that type, and we hash that content, and that allows us to compare two types very quickly. So we prefix with a class and then already added a hash to it. Now, why is this useful? Now, imagine I want to add another logical node. So say silo, right? So silo has as a default selected and a close and an open, and of course behavior. Now behavior is something that we already have written in the file, so there's no need to write that multiple times into the file. So what we can do now is we can save that. We can save that into the editor, and what happens then is that behavior will not be rewritten. We will not add another of the same structure. We also will not add another of the same enumeration type, just to save and reduce the size of the file. Now, this is why we use the hash format for our IDs here. Okay, so to sum it up, this plugin allows you to generate logical node types by simply selecting from the supertree being all the possibilities that the namespace of the i61850 provides you. You can extend that supertree with your own data objects or with data objects that are of type allMulti. You can preview the stuff that you will write into the file, and we make sure when we write the stuff in the file to really only add the content that you need to add in order to keep the file slim. Yes, so, and then we have the template updater. So in case you have forgotten something about the data type template section, you can go to the template updater. The template updater is also useful to look into current structures in the data type template section. We use the same approach as with the generator. We use the NSD file to show you the complete possible tree of a logical node type. But we show you what is in the SCL file of that maximum possible logical node by highlighting the selected. So this behavior, for example, had behavior in, we had indicator 1 in, we had indicator 2 in, and then we had ma trip in, right? So this is a nice way to look at the tree of the data type template section of your L node type without jumping from one type to another, which is what you sometimes do at the moment when you work in an editor to understand these types. Now, and then in addition to that, you can also add other types to it. So let's say I have my indicators here that I've selected. So indicator 1 and indicator 2, and I would like to add another one to it. So indicator 3, you see, and the indicator 3 has the same structure as indicator 1 and indicator 2. Of course, it's an SPS, and then I can select that, and then I can update the logical node. So I take that logical node and I add an indicator 3 to it. In the background, what we do is we create a new type. So we generate a new type that is positioned next to the old type, and this plugin will in future then offer you cleanup features afterwards. So in case you are using this type, you may want to create a new type. You may want to use this type in an instantiation of your ID or something else, and then we will allow you to do updates automatically. At the moment, it's positioned next to each other. All right, thank you very much for listening. I hope I could give you a little bit of an understanding how you can use these two plugins to manipulate the data type template section, and hope to see you in the community.